So today's lesson will not be on your quiz on Tuesday, but it will be applied for the rest of the chapter and actually the rest of the year. So radical review is what you did in algebra last year, but we're going to be using it so often in geometry that you want your skills to be very, very good when we start applying it. So for number 1, we need to find the square root of 64. Remember, what a square root means is what are the two numbers that are exactly the same that multiply to get to 64? That's what it's asking. What are the two of the exact same numbers that multiply together to get 64? Okay? Those two numbers that multiply together to get 64 are 8 and 8. Some of you probably just already know that because you have it memorized. What makes this more difficult is when you have to take the square root of 28. Now, in previous years, in like middle school, you would just type it in your calculator, you would get a decimal. But in geometry and later math classes, you need to write it in simplest radical form, is what it's called. So because the square root is essentially asking what two numbers that are exactly the same that multiply to 28, okay, there are none, okay? So a way to write it in simplest radical form is to find what it says on your sheet is buddies, or I call them pairs of numbers, because those two pairs of numbers, when you see a pair of numbers under the radical, you can take that number outside the radical. So let's do this example with 78. So what I'm going to do is I'm going to break 28 into its prime factors. So I first think, okay, what times what gives me 28? And the first one I thought of was 4 times 7. That was just the first one. You could do 2 and 14 if you wanted as well. You'd still end up with the same thing. Then you look at these two numbers and you try to break down any more of them you can. So 4 I know is 2 times 2. And 7 is prime, so I can't break it down anymore. So now that I see my three numbers that I cannot break down, I'm going to look for those pairs. So I see a pair of 2's. So I'm going to be able to take a 2 out of the radical, and I'm left with radical 7. This is simplest radical form. Notice that I used a different color for these. That might be a little helpful for you as we go along here. So if I look at number 3, I have to break down 63. So 63, the first one I thought of is 9 times 7. Then I'm going to keep going. 9 I know is 3 times 3. And sure enough, I can't go any further. So I look for my pair. I see a pair of 3's. If I see a pair, that means I can take that 3 out of the radical, and I'm left with radical 7. Simplest radical form. 180. Now some of you might start with a certain or a different pair. The first one I thought of was 18 and 10. And then I'm going to break down 18. What I thought of is 2 and 9. And 10 is 2 and 5. And then the only one I can break down now is 9. So 2 from before, and then 9 is 2 3's, a 2, and a 5. So if you notice in this problem, we actually have two pairs. We've got a pair of 3's, and we have a pair of 2's. They don't need to be right next to each other, because multiplication is commutative, but there are a pair underneath. So what I can do is I can take a 3 out and a 2 because there's a pair, and I'm left with that radical 5. That's the only one left over. What I do with these two numbers outside the radical is I multiply them. So 3 times 2 is 6, so this is now 6 radical 5. That's simplest radical form. If I already have a number outside the radical, I'm going to approach it the same way. I'm going to break up 300. So I'm going to go 3 times 10. So 3 times 100, sorry. So I can break down 100. Now I'm going to show you a little shortcut here. Now 100, what I thought of first, is 10 times 10. Now even though I can break these down, I'm not going to. Like I can break 10 into 2 and 5, both 10s into 2 and 5. But if I see a pair early on, I can take that pair out. So without simplifying anymore. So I get a 4, I'm going to take that 10 out, and whatever's left over stays underneath the radical. So 4 times 10 is 40, so 40 radical 3 is that in simplest radical form. 2 radical 264. Okay, now I'm not positive right away what 264 is like in my head, but I know it's even. So I'm going to start with 2, and then if I divide 2 into 264, I get 132. Okay, same thing again. I'm going to break down that 132. So I get 2, and then that is 2 times 66. And then 2 times 2 is 66, I know is 6 times 11. Notice as I'm doing this, I'm rewriting this every time. And then 6 is 2 times 3, and then 11. So now I'm looking for pairs. Since all these numbers are prime, I see a pair of 2's, and that's it. So the 2 from before, the 2 I can take out. And then everything left over, I'm going to multiply out. So what I'm left with is 4 radical 66 as my answer. When I multiply, now these are already done for you, number 1. Okay, you're going to put them underneath the same radical. So if I look at number 2, okay, essentially what this is, since they're both square roots, this is really 70 times 28. You can put them underneath the same radical with multiplication. And now you're just going to be breaking them up into pairs. Okay? So 70 is 7 times 10. 28 is 4 times 7. I can keep going. 10 is 2 and 5. 4 is 2 and 2. Notice how I'm rewriting all the numbers so I don't lose track. So I'm looking for pairs. So I have a pair of 2's. What else? A 7's. Again, it doesn't matter the order. They don't need to be in order underneath them. So I'm going to take a 2 out, a 7, and I'm left with the 2 and the 5 underneath the radical. So I'm left with 14 radical 10 as my answer for number 2. Number 3 is already done for you. Notice they combine them together. So if I were to look at number 4, what I do is I put the 2 out front, and then I put the 12 and the 54 underneath the same radical. So these two terms, okay, you can put underneath the same radical because it's multiplication, and this 2 from before, I put up at the front. So now I'm going to break down into my pairs. So 12 is 4 and 3, that was the first one I thought of. 54 is 6 and 9. And I'm breaking them down even more. 4 is 2 and 2. 7 3, 6 is 2 and 3. 9 is 3 and 3. So I'm going to look for pairs. So I have a pair of 2's. Got a pair of 3's, those 2, and another pair of 3's. So So the 2 is out from before, the 2 pair, the 3, and the next 3. So there's a lot up there. And then I'm left with radical 2. So if I multiply this all out, I'm left with 36 radical 2. Okay. Now, this one's hard, okay? You do this quite a bit in Algebra 2, very, very often, and in geometry. But what you're going to do with these division problems, like number 1 is already done for you, and there's some space on the left side of your paper. So what I would do first with these problems, so the steps with the fractions, is you should first test for perfect squares. Okay. Second step is reduce if you can. Three, this is going to sound kind of goofy right now, but you're going to multiply by fancy 1. That's what I call it, a fancy 1. And then step 4 is you're going to simplify. So those are the 4 steps for dividing fractions. So for step 1, I know it's already done for you, but the first step is test for perfect squares. When you take the square root of an entire fraction, you're essentially taking the square root of the numerator and the denominator. Okay, so if you take the square root of 81, you get 9. Square root of 49, you get 7. They're perfect squares. So that's all you have to do for that one. If I look at number 2, though, if I do step 1, test for perfect squares, there are none. Okay? Next thing I do is I see if I can reduce it. And I can't. So this third step is this fancy 1. Okay? So rewrite it so you see it as a radical 8 over radical 3, which is fully legal. And what we're going to have to do is rationalize. Okay? So rationalizing the denominator means you need to eliminate that radical. That radical should make you want to throw up. I joke around with the Algebra 2 students that you get like a gag reflex just looking at that because it's so disgusting. So you have to eliminate this. So what I'm going to do is I'm going to multiply by a really weird looking 1. Okay? My weird looking 1 is going to be radical 3 over radical 3. It's technically 1. Okay? It's technically a 1. Radical 3 divided by radical 3 is a 1. But the reason I'm doing this is I'm going to eliminate that radical in the denominator. So you'll see in a second why I picked that particular 1. It's not the same for every problem. Okay? So on the numerator, when you multiply fractions, you multiply across. So on the numerator, you're going to have the square root of 8 times 3. Okay, so that's from the 1, the numerator. Okay? All over radical 3 times 3. Now watch magic. Okay, I'm going to leave the numerator for now. I'll do that later. But on the denominator, look what I just created. I just created a pair. Okay, I got a pair of numbers. Just like what I did over here. When I got a pair of numbers under a radical, I could take it out of the radical. So if I took that pair out, I'd be left with just 3, which there is no radical in the denominator anymore. Okay? So that's at step 3, fancy 1. The fourth step is you have to simplify. So if you look at the numerator, that's why I didn't touch that right now, is I have an 8 and a 3, but that 8 I can break down a little bit. So I'm going to rewrite this. I'm going to break down that 8 into 2 times 4, and I can break up that 4 again. Now, these are going to seem like they take a long, long time, but you're going to be very efficient at it, I promise, as you keep doing it. Okay? So, I have a pair of 2's. So I take that 2 out, and I'm left with radical 6 all over 3. Now to decide if this is simplified or not, you need to check the numbers that are not under a radical, so the 2 and the 3, and you have to decide if those you can simplify. In this one you can't. And then you have to check for numbers that are both under a radical. So some people think you can do something with the radical 6 and the 3, but radical 6 is under a radical, 3 is not. So this is done. That is simplified. Simplified radical form. Example 3, notice that they checked for perfect squares, tried to reduce, did a fancy 1, and simplified. Okay? So for example 4, okay, first thing you do, check for perfect squares. 48 and 14 are not perfect squares. Second step, can I reduce them? I sure can. They're both underneath a radical. Since they're both underneath a radical, I can simplify this. Since 2 goes in both, this can reduce to radical 24 over radical 7. That's going to make things a lot easier for me later on when I do this problem. So I reduced. Now I'm going to do my fancy 1. My fancy 1 is going to be a little different. I can't have this radical in the denominator, it's disgusting. So I need to pick my specific 1. My 1 I'm going to do is a radical 7 over radical 7. Notice it's the exact same as the denominator. Okay? The reason this works, on the numerator I have the 24 and the 7 when I multiply across. But on the denominator I have the 7 and the 7 I purposely put there because what happens is I get a pair. And that's the whole point, is I eliminate the radical in the denominator. So now I'm going to simplify. So 24 is 4 and 6. Okay. And then 4 is 2 and 2. 6 is 2 and 3. 7's prime. And sure enough, I can take out a pair of 2's. So my answer, the case so far with this, is 2 radical 42 all over 7. Check to see if you're done. Are the numbers not under the radical able to simplify? 2 over 7? No. And then we already broke down the radical, so that is done. For adding and subtracting radicals, the first step you need to do, I already know this is already done for you, is you first should simplify all radicals. Next, add like terms. So when you're adding radicals, okay, very different from multiplying. Okay, when you're adding, you need like terms. Just like if this were a variable. So yeah, for this problem, you had 3 radical 2's, then you had a negative 6 radical 2's, and then you had a 1 radical 2. So if you have 3 radical 2's and you subtract 6, you now have negative 3 of them. And if you add 1, then you're at negative 2 radical 2. For these, I have to do the first step. I have to simplify radicals. Radical 11, I can't do anything. 6 doesn't have any radicals. I can't do anything there. 44, I can break up. 44 is 2 times 2 times 11. Here I have a pair of 2's. Plus 6. I can take out. So I'm left with 2 radical 11. So now you're going to combine like terms. These two both have like terms. They're both radical 11s. I have 4 radical 11s and another 2 of them for a total of 6. This plus 6 doesn't have any radicals on it, So you just add it on, and that's it. You can't combine them. It's kind of like a problem where it was 6x plus 6. You can't combine these terms because they're unlike. That's how these are. Okay, so it's kind of like that. Okay, squaring a radical. Squaring a radical undoes the radical. You'll see why in here. What the book did or what the worksheet has is a little different than what I'm going to show you. Remembering squaring is multiplying by itself. Watch what happens. You get a pair. Squaring a radical undoes the operation. So if you're square rooting and then squaring, they undo each other. You're left with underneath. If I'm doing 3 times radical 2, I need to square it. So I'm going to multiply it to itself. So I'm going to multiply 3 and 3. And then I'm going to multiply radical 2 and radical 2. So that turns into something like this. Sure enough, I get a pair. So what I'm left with is 9 times 2, which is 18. Notice I squared 3 is 9. If I square a radical 2, I get 2. 9 times 2, 18. 6 radical 6. Same deal. I do 6 times 6, 36. Radical 6 times radical 6. I get a pair. 36 times 6, 216. 6 squared is 36. Radical 6 squared is 6. And you multiply. Number 4. 4 radical 8 times 4 radical 8. 4 times 4 is 16. Radical 8 times radical 8 gives you 2 8s under the radical, which gives you a pair. 16 times 8 is 128. Notice, 4 squared is 16. Radical 8 squared is 8. That's the shortcut, but the reason it works is because what I have here. So if you haven't already, make sure you write out those steps. That's the only way you're going to get credit for watching this video. So there were steps on the division, and then there were steps on the simplifying if you did. So make sure you write out all those steps.